Hello everyone, my name is Chen-Kang Lee, and today I'll be giving an overview of the false negative denoising framework that we came up with for distantly supervised relation extraction tasks. It is a paper coming out in the findings of ACL 2021, and it's authored by Zhi-Wei Chen, Zhi-Rui Fu, myself, and my advisor Wei-Yun at the Institute of Information Science at Academia Sinica. The problems that people often faced when trying to solve information extraction tasks using deep learning is the lack of labeled training data and the general high cost that comes with trying to generate a dataset of their own. Distant supervision was proposed as an efficient way to generate large quantity of training data by aligning triples in a knowledge base to a large unannotated corpus. Distant supervision introduces both false positive and false negative noise. The third sentence here is an example of false negative noise. It is only labeled negative since the triple is absent in the knowledge base. Unlike previous works, which often focus on dealing with false positive noise, we decided to tackle the false negative noise in this work. When trying to denoise the false negative samples, simply removing them could result in a loss of potential positive learning instances. Instead, we design a denoising agent to generate one of three actions on each negative samples, including keep, discard, and revise. The keep and discard actions are pretty self-explanatory. The revised samples requires an additional classifier to generate the positive label for the samples to be revised to. We use reinforcement learning to update the denoising agent. In each epoch, the agent generates actions on every negative samples in the training and validation set. Then the classifier predicts new label for those samples that are tagged as revised for both datasets. Then the classifier is trained on the training set and evaluated on the validation set. The F1 score is used as the reward to update the denoising agent. For the experiment, we evaluated H-FND and other baselines on datasets with both synthetic and distantly supervised noise. As we can see from the figure, H-FND achieves performance comparable and sometimes surpasses that of state-of-the-art models, especially when noise levels are high. On real-world distantly supervised datasets, we can see the same trend. Our model performs especially well when high recall rates are needed. That is our work. Thank you for your attention, and the code can be found at the following GitHub repository.